Hi, everyone. Hello. My name is Simona Milanovic. I'm the Android dev role working at Google on Jetpack Compose. Thank you for joining me on this talk today. We're going to talk about how to design for scalable Compose APIs today. So, the basic building block in Jetpack Compose is the composable function. So when you build UI, you write many functions and functions that call other functions, and this in turn makes you an API developer. So whether you're developing on your own or in bigger teams or just as part of larger apps, or if you're working on creating a reusable library, establishing these clear guidelines will help you write high-quality Compose code that is more scalable, making it easier to evolve in the future with minimum friction. More consistent across the Compose ecosystem, making it more intuitive and following known patterns. And that guides others towards better practices by setting the right expectations and encouraging good design overall. So in today's talk, we're going to cover best practices and guidelines for developing idiomatic Compose APIs, which is based on our own experience of creating Compose libraries. So this comes as 3 parts, which is the first, how to think about and how to plan for your components, how to leverage the Kotlin and naming conventions and define a solid structure for your component, and finally, how to verify and maintain these APIs. So depending on whether you're developing for or doing framework contributions to Compose, external library, or app development, the following guidelines might vary between optional recommendations and strict rules. For framework development and contributions to Compose, these guidelines should be applied as strict rules. For external library development, it is a stronger recommendation that you apply these guidelines as much as possible to set the expectations and consistency of your API users, but also allowing stylistic guidelines to be a bit more relaxed. And finally, for the app development, this is often defined by your internal organizational priorities and requirements, which means that it can diverge from these stylistic and structural guidelines. So for app development, consider these guidelines as recommendations, but also do consider what is best suited for you, your app, and your team. In this talk, we're going to mostly cover the recommendations for app and library development, but definitely framework developers can still benefit still from this a lot. This means the guidelines are strongly recommended and should be followed where sensible, but are not strict rules. So some of this talk might kind of differ from what you've already implemented in your apps and how you build Compose APIs, and that's totally fine. We're here to kind of provide the guidance and the tips and share our own personal experience in this area while we built Compose APIs, give insight into this approach and why we did it the way we did it, and we hope that this actually helps you make a more informed decision. So let's start by going through how you would decide to even create a new API, like from the very scratch. We're going to be using the example of a filter chip component as a component that's kind of familiar to us. It might seem obvious at first thought, but have you actually thought about the actual steps in designing a component that you use so often? We're going to start with, obviously, an idea. So if you get an idea for a new design component, you need to start asking yourself, is this API meant to solve a single problem? For us, we needed a component that's going to represent a concise option for the user from a limited selection, and that's why we came up with a filter chip component to solve this specific problem. But why make an API that seems kind of similar to a button component? Chips and buttons both provide visual cues to prompt users to take actions and make selections. However, buttons appear consistently and with familiar calls to action, strongly impacting the progress and pulling these significant actions. While chips are the ones that are made to be dynamic and appear as more interactive elements, enhancing the overall experience and encouraging interaction. So splitting the chips and the buttons into 2 separate components actually follows this rule, which is one component, one problem, solved in one place. This ensures that the API is use case based, making it easy and clear to use. But if you need the filter chip to do a bit more, like representing suggestions or quick actions, this could be a signal to you that these additional problems should be solved in a different place, which leads to our next design question. If your idea spans multiple problems, you should try to break it down into separate components or layers. Now, for us, we quickly found the need for more variations of the filter chip, components that have a very similar UI, but also different purposes, like displaying generated suggestions, smart quick actions, and concise user input. So how do we approach this? Do we create lots of customization options on the filter chip so that users can actually transform it completely? Or do we create variations of it as completely separate components? If your app designs have a consistent requirement for more opinionated but somewhat similar variations of a single component, then it could be a good signal for you to build new components or layers on top. Layered, higher-level APIs like these are more constrained and provide very specific behavior, more opinionated defaults, and fewer customization options. Layers, however, are built usually on top of these extracted lower-level components, like a generic chip, which define a common surface and expectations for all the component variations. Simpler low-level components like this should be more open for customization, which means that we're going from lower-level to higher-level composables. There is an increase in opinionated behavior ingrained and a reduction of open customizations. And that's how we opted for new layers of assist, input, and suggestion chips. Layering decisions like this are closely coupled with your design requirements, so try to make an informed decision where to draw this design line, which can sometimes be a bit vague. Now, while creating filterable API, like a filter chip, might seem justified, what about a chip group, like a layout that would rearrange these chips in a selected orientation and apply some extra styling? So let's try to break this down. Arranging chips vertically or horizontally is very easy, and you can achieve that with existing APIs like the column or row composables. The styling can be handled via applied modifiers or separate decorations. So this means that there are no custom behaviors or decoration coming from this chip group API. We can achieve everything using existing APIs, existing blocks and concepts, so this is a good signal we might not need this new API. The API needs to bring value and justify its existence, because the creation maintenance of custom APIs does require some work, as well as learning how to use them from the user side. So try to understand whether to create a new component or delegate to existing ones. Now, we envisioned a chip component that with a specific purpose in mind and with a distinct UI that follows it that cannot be easily applied to other components. So we decided to create a new component. However, if we just want to make something selectable or clickable as a transferable feature or a behavior that can easily be applied to multiple components, we would create this using a modifier API and obviously not as a custom component. So to kind of quickly recap this first part of the design process, we start with a new idea for an API. And the next thing we have to do is, does this API solve a single problem or multiple? If we realize it's actually multiple, then we need to break them out into multiple components and kind of go back all the way to the start. However, if we realize that the API actually solves a single problem, then we can actually continue on and say that try to think about whether this API is actually a new component. Does it exist already among the composed APIs? Can you use existing APIs to kind of mimic it very easily? If so, try to rely on using existing APIs. However, if the answer is no, and you can't easily replicate with existing ones, then the next question to understand is how many variations or layers of this component we might actually have. In between this, as sort of like a sanity check, just think about whether this is truly a component or a transferable feature that we can actually apply using the modifier. If we do decide that we don't need any additional variations, then we obviously look into creating this new API. But if our designers or we ourselves have decided that we do need layers on top of this, then potentially, then actually go into the step of creating these individual layers separately. Cool, so the next big section is to think about how to write your API. Now that we have the filter chip component solidified, let's look at how to best actually structure it. Now, whether your API users are part of your own team or the broader Android community, following these widely adopted guidelines helps, for writing APIs, actually helps promote consistency and readability across the ecosystem and provides ease of use for everyone. Kotlin is at the very core of anything Compose related. So through this process, you should be following Kotlin code conventions and Compose-specific Kotlin patterns for style guidelines and things like contents, seal classes, and others. Naming is a good place to start this section. So by now, you probably adopted the Compose naming conventions, but have you actually understood why they are the way they are and how they actually work? If not, then we can actually start explaining different naming types in Compose. A composable function returning unit should be named using Pascal case and a noun with or without prefixes. This is why filter chip comes with a capital F, as it emits UI that can be added to composition, returns unit by default, so it follows naming rules for classes. This also helps the element establish this persistent identity across recomposition and reinforces the declarative mental model of describing UI with Compose. To differentiate between the unit returning types, for composables that return values, you should use the standard Kotlin code conventions for function naming with a lowercase. Composable functions should either emit content into the composition or return a value, but not both. Any composable function that internally uses remember and returns a mutable object should be prefixed with remember. This helps clearly signal its nature and potential of persisting through these recompositions. Components without a prefix can represent basic components that are ready to use and somewhat decorated. Consider using a basic prefix for APIs that are bare bones with no decoration, because this is a clear signal to the user that they can wrap this in their own custom decoration and that the component is not meant to be used as is because it's too bare bones. So remember that we decided to layer the chip component with a few specific additional designs. One layer or one level above it are the opinionated APIs, such as the filter chip or input chip, which signals that there are more stylistic variations. Try to prefer prefixes and names that are mostly derived from the component's use case or purpose, rather than using generic company name or module feature name as prefixes. Composition locals provide global-like values, which are scoped to a specific subtree of the composition. To signal this, you should name them using a descriptive name and use local as a prefix to them. So your API is kind of only functional as the inputs that it has or has access to, and therefore parameters are crucial to defining the API purpose and requirements. When thinking about your API structure, try to be explicit and descriptive. Explicit parameters make it easy to present the API behavior, adjust it, preview, and test and use. Descriptive inputs ensure that your API is readable from the start and easier for users to understand at a glance. Try to avoid, am I hallucinating? Or did that just flicker again? Okay. Avoid implicit inputs as much as possible, provided via composition local or other similar mechanisms, as these kind of obscure it and make it hard to track where the customization comes from. Instead, try to open up the API and use explicit parameters, which also makes it easy for users to add layers on top of with stricter customization. Another essential Compose component concept is our modifiers and how they define composables that they are paired with. Components are responsible for their own internal behavior and appearance, while modifiers are in charge of modifying their external behavior and appearance. So using modifiers makes the component both customized and reusable at the same time. Modifiers should be at the top of your mind when you define the API parameters. Compose users already have expectations around when and how to use these modifiers, so try to make sure you leverage this in your APIs. This is why every component that emits UI should have a modifier parameter that is of modifier type, so that any modifier can be passed. Is the first optional parameter, so it can be used without a named parameter and has a consistent positioning in your contract. Has a default no-op value, so no functionality is lost when users provide their own modifiers appended to this existing chain. Is the only modifier of top modifier in the parameter list, although one should be enough for a single component, but this can vary depending on how deeply the nested component you have is, or components. The need for having multiple modifiers might signal that you need to rethink your other parameters or break your API into multiple. And this is also why the modifier should only be applied once to the root outermost layout of the component. So if modifiers describe the composable behavior and appearance, then you might ask yourself, like, when will I use explicit parameters compared to this? Like, how do I tell the difference? Every API has crucial core parts to it that represent its behavior and UI, and these should be explicitly asked as parameters as an indication of the API's main purpose. Modifiers is also super powerful, but they can't do really everything, and hence why explicit parameters should also add behavior or decoration that cannot otherwise be easily added via modifiers. If, however, there is a non-core modifier-supported customization, then use a modifier. Now, when defining the ordering of your parameters, try to think about the API readability and ease of use. Its signature is basically an implicit instruction to the user on how to use this API. What is its purpose and what are the customization options provided? Consider listing the API parameters in the following order. Require parameters first, without any default values, indicating the purpose of your API and what is needed for it to work properly, so they can be used without named parameters. After that comes the modifier, making the API customizable and aligning with the compose expectations. Then come the optional parameters with default values that can be overridden by user or not, requiring the usage of named parameters. Additionally, you should or could group parameters that are semantically similar, like putting textual inputs together, click events, styling, and similar. And finally, the trailing lambda composable named content, which represents the nested slotted content of the API if it requires one. This is a common concept in Compose that we're going to cover a bit later. Setting the default parameter values and using nullability to signal absence of value can provide a meaningful description of the API. So try to choose with this with care and think about it. There's a difference between a default value, empty value, and an absent value. Nullable parameters hint that this API feature is available but might not be required at all for your use case. The choice is going to be yours. A null value, however, is not the same as an empty one, because empty defaults signal that this API feature is required and can be used with an empty value, or to be overridden with a more concrete one, based on your use case. All other default values should be non-null, meaningful, and also clear to the user. They need to be publicly available so the component gives the same consistent result in any place where it's called. Try to rely on if-else statements to describe this conditional usage of different default values. A subset of your parameters is most likely going to target styling and customization options. So a good practice is to provide default values for these parameters so that the API is independent and can be used as is. If styling default values are short and predictable, then it might be enough to keep them simple inline constants. However, some APIs like the chip can have a long list of customizations, different shapes, colors, border states between enabled, disabled, etc. So if you find that your API requires a lot of default values of similar type, you can use component defaults objects to map them externally in a single place. You need to ensure that these objects are publicly available so that the component can be used anywhere, for example, by adding them as part of your theming. Styling can also be conditionally set based on different states, like how a chip can set a different background color based on the selected state or borders. Handling conditions can also be delegated to this defaults object. And you can, again, rely on simple if-else statements to define this like kind of branching logic. Extracting defaults into the component object might seem like it's actually clashing with the recommendation of layering multiple components. So why would you have separate layers if all you can do is just establish a different component default for each type? Keep in mind that component defaults only hold a very small subset of explicit inputs such as colors, borders, etc. This component is still going to be very much open to your free customization. While these layered high-level components are highly opinionated in a variety of these styling options, and they allow less room for this kind of customization. So the choices you're going to make here are highly dependent on your own specific use case and design requirements. So try to draw the line, again, wisely between keeping things simple and polluting the API contract. Now, another concept that is very often used in Compose is our slot parameters or slotted content. These are composable Lambda parameters that specify an open space inside the parent to be filled with child ones. For chips, for example, we wanted the user to have the option of inserting text, image, icon, or any other content. So for a single slot, the Compose way is to position it as the last parameter of the composable API, so it ensures consistency across components and that it can be used as trailing Lambda. So if your API requires multiple slots, like, for example, the chip and the label, the chip icon and the label individually, you can provide multiple parameters of such type. By using slots, the chip doesn't care what's being passed at all as the nested content and focuses only on handling its main responsibilities like the choice selection, click handling, which gives more flexibility to the API user. This also simplifies the main API contract by only taking in the information needed for it and delegating everything else to the user, of the user to the actual slot. Another interesting concept, very handy, that can be used in combination with slots are scopes. This is especially important for single content slot APIs, as scopes define an appropriate layout strategy to use in combination with the slot Lambda. If your API design dictates using a single slot, think about how this component is meant to be laid out when the user passes one composable, or when they pass multiple composables, because they can. Should they be laid out in this like row-like formation, or one on top of the other like a column, or maybe even stacked in a box? For the chip, the most common usage pattern is to lay out the icon and the label side by side in a row. So what we do is we actually scope the content slot to the row scope. This ensures that somewhere down the line, this content needs to be invoked within a row composable, and at the same time, it communicates this UI expectation to the user at the same time. So another potential good example of scopes could be column scopes or box scopes, and they're also good candidates for this layout strategy. Modifiers in Compose can also be scoped to an individual layout in Compose. This kind of provides type safety and protects you from trying to use a specific modifier in a composable where it makes no sense to use it. For example, if you take the weight modifier, which, as you know, defines sizing priorities of nested children in lists. Using this modifier outside of these lists makes no sense. So we scope the modifier by using a pattern of scope interfaces and scope instances. All of this uses parent data modifier under the hood. Parent data provides data to the parent layout from its child composable, can be read during the layout phase of measurement and placement. And it's commonly used to inform the parent on how the child layout should be measured and placed. This is a very broad topic, so we can't really go any further than this, but if you want to take a look at the implementation of something like this, look at our jet-lagged compose sample and our custom layouts and graphics talk. The chip API now has a relevant name, which is carefully defined alongside the inputs and the styling and nested content. But we also need a mechanism in place that is going to manage the changes that are happening inside and outside of the component. And this is where state comes in. We needed the chip composable to have an enabled and a disabled state, a property that can be changed very frequently and impacts the UI a lot. Changes in composables can be handled in two ways. First one is stateful, with the composable owning and handling its own state via APIs like remember or mutable state of, or statelessly, where you rely on the composable being called and recomposed with different inputs and rendered in a different state. Wherever possible, try to prefer the stateless composables that hold no state on their own, but instead accept the state as input and are controlled by the user or the caller. This makes the API more reusable and more testable, as the external caller is able to dictate these changes and your component just follows this. Extracting the state control like this is called state hoisting, which is a common compose practice. The enabled state is now hoisted and outside of the API control, but the chip still needs a way of handling clicks and signaling it to the caller that it has been clicked. Events such as onClick should be accepted as as Lambda parameters and passed accordingly. Extracting events like this ensures that your API is more reusable, testable, and previewable. So when the functionality of your API grows, the main API states might become very complex and very lengthy. At that point, you could extract logically grouped states and callbacks to a separate state holder or a component state to allow your callers to hoist this state up with ease. For app developers, you could do this using plain classes as a simplified approach if your API is kind of meant to stay limited internally. However, if you're building for external usage or like a 3P library, then consider using interfaces, because this opens it up for you to provide the default, a different default implementation and custom state synchronization if you need it. Hoisted state holders only kind of work as intended if they contain properties that trigger recompositions when changed. So your API is corresponding to the change as intended. This means you're relying on Compose's snapshot system, for example, through mutable state of, so that the UI can actually be observed and react to the property changes. And secondly, that if it persists the latest values across different recompositions, which means the API matches the UI, it matches its UI with the latest state that is valid in a reliable way. And this means providing the hosted state of the composable as a remember with defaults in place to persist recomposition. To understand and address the stability requirements of these hoisted states, make sure to go through the documentation, as it is a broad topic. Cool, so as state can actually be kind of a delicate matter to handle, avoid passing state, mutable or immutable, as a direct parameter of the API. Passing state like this means that there could be multiple owners of it, both the caller and the composable, which kind of complicates control and creates multiple sources of truth in parallel. Instead, try to prefer explicit inputs. Where possible, make the composable stateless by passing non-state arguments like strings, ints, or even lambdas, and rely on composition to do its magic. Cool, so structuring the API component is a big part of your process, but after we're done with that, we still need to ensure that the API satisfies other important requirements like accessibility and testing, that it comes with the right documentation, and backward compatibility. Basically, that your API is set up to be solid and reliable for long term. And this is part 3 of the design process. So to make sure that your API is supportive of different users with different needs, ensure that it is able to reliably and logically transform what's shown on the screen to a more fitting format. Compose uses semantic properties to pass information to accessibility services. Lower-level building blocks, like clickable modifier, and composables like, for example, image, they have a predefined way of handling accessibility. They either provide good defaults or explicitly ask for this information. However, when you create a higher-level API yourself, you might need to specify and request more information to understand how to describe a UI element properly to the user. So, if your API is required to have an explicit semantic set, you should request it as a non-optional accessibility parameter. If you think about the image composable, it actually has a required parameter, content description, to signal the need that this is a necessary description. To apply this to the filter chip component, you could specify the same and apply it via modifier semantics to the root component. However, when designing components, it's important to make an informed decision what to build into the implementation versus what to ask the user explicitly, because you need to keep in mind that your users can actually provide their own modifier semantics and try to override your default setup. And this is why you need to think about where you might need explicit accessibility parameters. Aside from requesting explicit parameters, you could also rely on the slotted content semantics as a more sensible or logical choice. The chip API comes with 2 slots. These APIs don't necessarily need to explicitly set the text for accessibility services to read out. So when it is contextually appropriate, the slotted content semantics can be actually made from the icons and text accessibility semantics as a more logical solution. This is called semantics merging for accessibility. It's often used in Compose. So to have the chip merge all of its children into one for semantics, you can set the modifier semantics merge the descendants true, and this will force the descendants to collect and pass the information back to the parent component so that it's treated like a single entity. The rule of thumb here, simple components typically require 1 to 2 semantics, whereas more complex components might require more, like for example, text fields or scrollable containers. If you need some sort of a guidance, what you can do when you're developing a component is you can compare your API to an existing one, find the one that's most alike, copy its semantics implementation to start with, and then start fine-tuning it step by step so that it matches your own use case. When creating a new API, you need to think about how it will be used for building UI as well as testing UI. So checking how testable your component is in isolation is a good indicator of a well-crafted API. Well-designed components are easy to test by themselves, alone, or as a part of a larger composite component. So let's look at ways to kind of maximize this testability. Try to think about whether your component requires platform-specific resources to work. For example, does it need a specific activity or context? If so, this could limit the testability of the API, because in tests and also in previews, you might not have access to these resources. So here we require access to context to launch an activity. A better alternative is to provide the click lambda as a parameter and delegate this responsibility to the composable caller. Implicit resources like context or composition locals can have a detrimental effect on the testability, so you should always try to aim for alternatives through explicit parameters. However, if you do need composition locals for styling purposes, make sure to put good defaults in place. When testing your API, you should be able to easily verify all possible states of this component. For example, we should test all of chip variations for selected and enabled states. Exposing this as explicit state parameters gives us access to this change, and we can easily verify it as we like in tests. While selected and enabled states are kind of easy to extract and invoke, there are some more complex system-specific events, for example, such as press state. To make testing easier for these components, for these events as well, you can use and hoist the interaction source. This lets you emit and verify interactions in states such as the press interaction. A quick tip here is that having a modifier parameter allows API users the test tag to pass a test tag, which helps identify elements in tests more easier when other matchers are not very specific, not specific enough to find that. And finally, for long-term stability and maintenance of your API, consider writing the appropriate documentation, which should follow the KDoc guidance and syntax, and should clearly communicate the API capabilities, description of its purpose, parameters, expectations around those parameters, as well as usage examples where possible. Usually, this can start with a one-liner paragraph, which is enough to kind of summarize the component and what it does. Then it can follow more paragraphs, which go into more details around these components, outlining the capabilities and the behavior and the samples, or potentially even pointers to other APIs. And finally, the description for each parameter using the param tags. And if you're developing for external usage, you need to ensure that backward compatibility is supported and in place. Since every composable is basically a function, there are some rules to follow here and watch out for. As, for example, not removing existing parameters, adding default expressions to new parameters or of existing functions, adding new parameters as the last parameter or second to last in the case of trailing lambdas. You might decide to put new parameter closer to other parameters that are kind of semantically closer. But for in-depth documentation on this, make sure to go through this. And this kind of brings us to the end, and one good-looking, well-structured API, which is the chip API, and this one is planned around solving a single problem, has different variations of opinionated components or layers, is named carefully and descriptively. It has the right explicit and mandatory and optional parameters, well ordered and with the right defaults in place, which accepts slot as nested content and is adept at handling state. And on top of this, it supports accessibility and testing requirements and is user-friendly with concise documentation and backward compat in place. So since in Compose, kind of everyone is an API developer, we kind of hope this equips you with enough knowledge and insight to create components that are more maintainable, more scalable, and consistent across the Compose ecosystem that is growing daily, and that it guides your users towards better practices. And for all of this, but in much, much, much more detail, you can take a look at our Compose API guidelines documentation. And thank you very much.